Hey Lexi, and welcome to your TP2 homework recap thing. Hope you're doing good with the exams. Hope you don't fail. Please and thank you. Anyway, homework 1 was really just partial derivative practice. As you can see here, the only thing of note really was what a total derivative is, which is just this thing here that you're seeing on your screen, which is just like the partial derivative with respect to some variable times the sort of integration element, derivative element, whatever that's called, of that same variable. It can go on. You can also have a z version of this, dz times dz. Yeah. Tips here are basically just like, don't be dumb, fully do out a chain rule, fully do out a product rule, convert squares and fractions to indices, because it's so much easier. That's just how you differentiate. For example, this root, we'll turn it into x squared plus y squared all to the half. And take your time with and fully write out indice multiplication and division. Just because I messed up a question, just please write it out fully. Don't do it in your head. And this is just like sort of general, just saying, hey, remember this. Spherical coordinates r is equal to this sine theta cos theta. Nope, that's wrong. Sine theta cos phi. Sine theta cos phi, sine theta sine phi, and then cos theta. The theta unit vector is equal to the theta derivative of that r unit vector, and then to find the final phi unit vector, you just find just cross multiply these two. The cross product between these two is the word I'm looking for. Yeah. Just remember that. I don't think you have to remember any of these special things. That's fine. Something of note is that a circle's thing is this. Sorry, my brain's a bit broken. A circle's position vector is going to look like this. These are supposed to be rows. And you can see it's cos phi, sine phi. Looks like a circle. A cylinder is going to be the same thing. Once again, these are rows. These are the radius. But you have an extra component. It's a z. And we'll see that later on, and you can see this is along the z-axis because it's essentially just a bunch of circles along the z-axis is what this shows. Just please remember. And also please remember sine, cos, tan. Okay, tan maybe not so much, but just don't be dumb. You know how to convert between degrees and radians. Just remember these things, and then you could draw out a unit circle, and figure out, you could figure out what pi is, or minus 2 pi, or 3 pi over 2, or whatever you need to figure out. I hope you can, or I hope you can get somewhere close, if you remember this. Now, just to say it out loud with me, please, class participation, or whatever. Sine goes 0, half, root 2 over 2, root 3 over 2, 1. And cos is just reversed. Cos is 1, root 3 over 2, root 2 over 2, 1 over 2, 0. And these increments are in 0, pi over 6, pi over 4, pi over 3, and pi over 2. So, yeah, that is basically it for homework 1. I mean, another thing of note in this homework was they asked what the slope of a tangent in the x and y direction to a surface was at a certain point. It's very simple. You just find the x derivative, y derivative, solve it in the points, and then show it like that. It was just it just felt worded a little bit weirdly. But yeah, order doesn't matter in differentiation. Yeah, don't be dumb.